Good morning, students. Welcome to online classes. In last class, we have seen the induction motor torques developed during starting period and a running period. We have also derived relations between full load torque versus starting torque, full load torque versus maximum torque. In this class, we are going to analyze how the torque is developed, and that depends on what factors. What is the relation between torque and speed, its curve? At the same time, what is the relation between torque and slip? Let us see one by one in details. On completion of this period, you would be able to know that the first one, draw a torque slip curve of an induction motor and synchronous watt. As you know that, as stated earlier, stable operation of an induction motor lies over the linear portion of its torque speed curve. The slope of this straight line depends mainly on the rotor resistance. Higher the resistance, sharper the slope we have seen previously. This linear relationship between the torque and speed establishes a very simple equation between different parameters of an induction motor. Okay, let us recall what we have seen previous classes at a glance. For this, we will see torque slip curve. Let us draw this is the torque, this is the speed. Okay, what we have seen in previous classes, once speed is equal to 0, that means the induction motor, when supply is given to this one, 3-phase supply, it produces its RMF, rotating magnetic field. This rotating magnetic field sweeps rotor conductors, hence rotor conductors also produce its own magnetic field. This field is generated such a way that it opposes cause of its production as per Lenz's law. Then this will try to reduce the relative speed between the rotor conductors and rotating magnetic field. Thereby, rotor will try to rotate in the same direction of rotating magnetic field. That means initially the speed of rotor speed at initially the 0 at standstill condition. Once it try to reduce the relative speed, rotor will slowly starts. That is called, from speed is equal 0 at this condition, the torque is 0. For example, you take the starting torque, how much you take it. Now, after some torque is developed. Equation already we have seen. Initially nr is equal 0. The speed developed, yes, the slip is equal to 1 maximum. What is the equation? That torque equation is equal to T directly proportional to the slip and voltage induced in the rotor whole square and rotor resistance divided by and Z, that is equal to Z2 R2 whole square plus Sx2 whole square, for example. Okay. So, this is the equation. Now, what is happen at S is equal to 1 maximum, X is equal to 1. So, T is directly proportional to S here. Okay. Then it will develops more torque in this case. Then initially it produces S is equal to 1 and rotor speed is 0. The torque is developed also 0 at this condition. Now slowly that is equal to, slowly the torque is developed, this is the starting torque. The torque is developed by drawing the current from the supply and go on increasing slowly, just is increasing when speed increases, and this torque go on increasing. Then the twisting force, what is that? The torque is a twisting force. This twisting, due to this twisting force, the rotor will rotate and pick up some speed. The speed is increasing. The torque increases, speed also increases. The torque is a means of how much a force acting on an object causes that object rotates. Okay. So, the object rotates about on its axis, then it is rotating. Now, the torque is go on increasing up to one stage, up to one speed, maximum speed. Then after that, the further increases on speed, the torque is slowly going to reduce. Once, that means the speed is increasing and slip is decreasing. So, we know that what is the slip? Slip is equal to ns minus n. N is equal to 0 initially. Now, the speed increases, that is the slip speed decreasing. Speed increases, and at that one condition, so here what will happen? This is the maximum torque developed in this case. At that condition, we can say this is the speed. After that, if torque decreases to linearly and it becomes to, torque becomes to 0 at once the nr, this rotor speed equal to synchronous speed. At that condition, S becomes to 0. That means n becomes to, this n becomes to ns and S becomes to 0. Then it is slowly decreasing. So, already we have seen, what do you call this one? This is known as the rectangular hyperbola. Rectangular hyperbola. Okay, the rectangular hyperbola, you know this already you drawn in drawing. What is a hyperbola? Okay, the shape is this is a unstable condition. This is a stable condition. We will see later. This is a simple relation between the torque versus speed. Initially, the speed is 0. The torque developed, starting torque is developed here, and the torque is slowly developed. Is a twisting force. The rotor will rotates. Speed will pick ups. The torque also pick ups. The speed also pick ups. torque increases, this all increases, this increases, this increases. Up to one stage, the maximum torque is developed. Then after that, the torque slowly decreasing and becomes to 0 when speed becomes to the nr is equal ns. Okay, so that purpose I am going to give some relations. So this is the torque versus speed. Okay, now I want to analyze the relation between the torque versus slip. Now we have seen the what is the torque versus, this is the speed, then speed 0, n is equal 0, n is equal ns here. The torque is increasing. Now I want the slip relations, the torque versus slip, that is the reverse of this one. Okay, now let us do that also. So what has happened here? Here you take it, for example, this is the, now in this case you can take the slip. Okay, s is equal to here 0, that is equal high speed equal to synchronous speed. Now this is equal, s is equal 1 stage, for example s is equal to s1, s2, and you can s2 is equal, you can say that this is a s3. Okay, and this is equal maximum, s is equal to 1. I am going to take the 3 stages. Now here in this case I am going to take the torque. Okay, now what is happen here? S is equal 0. What is the s is equal 0? What is the condition? ns minus nr, so relative speed by ns. Okay, now you take what is happen here, the rotor, our rotor speed, that is a rotor speed is a very high speed, n is equal near to synchronous speed. For example, take the P is equal 4-pole machine. Okay, 4-pole machine. What is the speed? What is the synchronous speed? Synchronous speed is equal 120 F by P. That is equal, we are going to get the 1500 speed RPM. Okay, 1500 RPM. So at that condition, the S becomes to the 0. In this case, this is 1500 RPM and rotor speed also 1500 RPM. Then S becomes to 0 value. Okay, so because already we have seen what we have seen, T is equal, torque is equal direct, that is equal K into E2, that is equal S into E2 whole square into R2 by, what is the value? So Z, that is equal Z square, R2 whole square plus SX2 whole square. So this is the equation already we have seen. Okay, now I am going to use this equation for analysis of this torque slip characteristics. Okay, now first you take the case 1 at S is equal 0. What is the S is equal? S is the, let us assume S is your interest in your studies. Before going to that one, I want to analyze this torque slip characteristics in the form of our experience. Okay, let us assume what is happened here. So this is your family, and your family relations, for example, take it relations. Then what is happened, your family relations? There is your father and your mother and yourself, always you are with your mother. Okay, now what is happened? So there is a relation, there is a prestige in your relations. So your uncle and your other grandfather, different relations. In relations you have some prestige. So that prestige, I can say that is equal, some prestige is equal T prestige. Okay. Now your interest studies, you are studying in polytechnic. Okay, that is equal, you are the going to the some yes, your name is a yes, and your mother name is a X, and your father name is a R. So we know the relation. What is the relation? So torque equation is the, what is the relation here? Now T directly proportional to, we can take the, okay, that directly proportional to S into E2 whole square R2 by R2 whole square plus SX2 whole square. Okay. Now what is happened here? So let us assume R is your father, S is yourself, X is your mother, the X2, you can take the X2. Now what is up? This is your family, this is your family. Now if initially you have the interest in your studies, okay, so what is your interest, your studies? Now initially your studies, yes, your interest in studies. If your interest in studies is equal, initially you are enjoying, then S is equal 0, your interest is in studies is equal 0. Then you may be failed, first case, failed in, for example, in diploma in first year you have failed. Then what is the prestige in your relations, in your total relations? That, so that is equal to 0, your prestige T is equal 0, total prestige will goes. Then what will happen? Your mother and father will take a class to you, then they will tell you, and you are going to realizing that thing. And second, the first case, your interest in studies are 0, then you are failed. After that you are going to realized after some counseling with your father and mother. You are slowly studying, slowly now you are going to increasing the your study. For example, your stage is, for example, that is the just you are now you are going to get the 30% instead of 0%. Now you are going to get the interest on your studies 30%. Then what will happen? Then your prestige in families increases. Okay, no problem, is picking. Now what is happen? If you know the taste of studies now, then you are going to spend your most of the time for studies only. Then your interest in studies increase to the nearly 100%. Then you are going to get the, you are the topper in the class and you are topper in the college itself. Then what is your prestige in your family? So you are dedicated and you have studied perfectly, whatever you are required, that's you have got it 100%. You got at least, you got it the university seat in JNTU or Osmania. Then what is the your Kandani prestige? So at state first in ESET rank, your name in newspapers. Okay, then that purpose you dedicated all your time and sacrificed your enjoys. Then you got it a good college seat. Now if further increases your concentration or interest by sacrificing all things, then what will happen? Your health may be damaged. Day and night you are spending for improving, then you became the, your health may be deteriorates. Then what will happen? So once again, oh, so the person health is not good, then your prestige also go on decreasing once again. If you are not bothered that prestige, if further increases in on your studies, then you are going to become your health will become the very poor. Then you becomes a patient. Okay, then your prestige in the family once again decreases. No one will care you. Then you become just like a mad person. Okay, so this is a one situation. That means here what is happen? Initially, if your interest is equal to 0, everyone is pointed you are the useless fellow. After some your interest increases, they will attract you towards you, they will praise you, and by knowing the taste, you are dedicated, sacrificed, and you are going to get it ultimate on his service. Then you are going to get your prestige is a top in your family and your relations. That is enough. You are still go on, so you are going to maintain that things, but what will happen? You are further increased your time, day and night. There is no rest to your body, you are neglecting everything. Then go on further increased, then what will happen? Your health may be decreases. Then once again your prestige decreased. Then you become the patient. So this is the situations may be occurred. Same maybe I am going to explain here. What is happened here? So here S is equal initially 0. Then what is the torque? Torque becomes to the 0. So torque becomes to the 0. Once, for example, S increases, then torque is directly proportional to the S. Your interest increases, your concentration, your prestige increases. At one stage, T is the maximum at S is equal to, so that is equal to where S condition, that is equal here the R2 resistance equal to X2. Already we have seen derived the condition for the maximum torque, R2 is equal to X2. That is called your support. Your dad, initially your support to your mother is 0 because your studies is 0. Your father is dominating here. Once you are going to increase your interest in studies, then what will happen? The confidence in your mother increases, and your mother and yourself equal to your father at this condition. Then what will happen? Your father equal to your mother, that is equal S into X to yourself and your mother. Then at that condition, so what will happen? So then your prestige torque becomes the maximum T max at this condition. Your father equal to your multiplication of your mother and yourself. Then both are equal. At that condition, the torque is maximum. If further increases, S is equal to increase, what will happen? So in this case, your prestige decreased 1 by S. Now your prestige may be deteriorate due to yourself. Your mother is same, but the value of product decreases once after maximum value of stock. Okay, so this is that means you can see it, the torque initially 0, torque initial before the maximum torque is directly proportional to the slip, and after maximum torque, the torque inversely proportional to the slip. You can observe that thing. Okay, so same thing you are going to see here. Good, dear students, please remember this one. So this is the torque equation. So how the torque is changes corresponding to slip. That means how your prestige changed based on your interest on your studies. Okay, now let us summarize it. Let us study here. So what is happened here? Initially at s is equal to 0. Then what is the condition? First case is equal to 1, s is equal to 0. That means what is the s is equal to 0? S is equal to b means the slip is equal to 0. That is equal to NR, rotor speed is equal to synchronous speed. Okay, so that is, this is a 1500 rpm, this is a 1500 rpm, s is equal to 0. Then what is the torque? What is the equation? S is equal to 0, torque equal to 0. Okay, this is the condition, point taken. First case. Okay, now case 2. We take the case 2. In case 2, then what is happened? Now when s is very low, that is equal here, where is the low? You can take this value range. Then sx2, s value is some significant value, then sx2 value increases, is very low, and even then we are neglected in comparing with your father R2. R2 is a very high. Now here sx2, s is a small, very kid, this one. The product of sx2 is some value that is a very low as compared to your R2. In this condition, so we are sx2 is a so we are neglecting this value. Okay, then what is the value we are going to get? So we are going to get it t. What is the t? T is directly proportional to, we are going to get s into E2 whole square by R2 only. That means what is the happen? So T is directly proportional to S. Okay, that means slip increases, torque also increases. Simply draw it. So here slip increased from 0 to S1, the torque increased. This one. Okay, that is the case 2. In case 2, slip slowly increases small value. Then S into x2, the product becomes the very low as compared to the R2, and Sx2 value is neglected and substituted in the torque equation, and we are going to get it, the T is directly proportional to S by R. If R is a constant value, resistance constant value, then so we are going to the T is directly proportional to the slip. Okay, now that is a linearly increased from S is equal to 0 to S is equal to S1. Okay, now the case 3. Now in case 3, here you can take the case 3. Case 3, what is happen? When the slip increases further, that means what is happen here, dear students, please remember that here what is happen. Now in this case, initially S is equal to 0 means our rotor stator speed is both are equal. That means there is no torque on rotor, there is no load on the rotor. We are not added any load on this rotor, hence both are moving at the same speed. At that condition, the torque is equal to 0. Now what is the speed? NR is equal to NS in this first case. Now we added some load on this motor. Okay, so because motor is the mechanical output, so this mechanical output is utilized for running our small application. Then what will happen? If load added in the rotor, automatically rotor retards, reduces its speed. Then NR is equal to less than the NS. then slip is developed. That slip is very low. For example, the 1500 RPM minus 1440. For example, take the NR is equal 1440 due to the some load, small load added. Then S is equal, what is it? This minus this by this one. So, we are going to S is equal to very, very low. Then, so that is a S becomes to now, in this case, S becomes a S1. Now, I am going to add another some load, some application added. I connected the another belt. First, I connected the one 3-phase induction motor to the some only wheat mill, and now here added the turmeric belt also for the turmeric powder, and when some you can take the wheat flour, and sometimes different they will use the different loads in domestic applications. Now added the some load initially, some this is equal, they become, and added further load, some load on the rotor, then automatically rotor speed will reduces. Now in this case the rotor is decreased further. Now instead of 1440, now it is going to the 1400 only. So automatically the speed will reduce. If speed reduces, what will happen? Slip increases. Slip increased in this case. Okay. Then so we can draw the slip in this case. S is increased. Okay. S is increased such a way that in this case when S increases, what will happen? Here third case, S increases such a way that when slip is equal to the R2 by X2, that means the product of SX2 equal to R2 rotor resistance value, such a way that the slip increased on rotor by adding some load. Then when the load added on rotor, the slip increases, that slip into X2 value, product value, when equal to the R2 value, at that condition we are going to get is the maximum torque, T max, maximum torque. What is the T max? That already we have seen. T max is equal, so we have derived the equation also. Okay. So previous classes we have seen T max. What is the T max value? So that is equal to, so already we have seen that is equal some E2 whole square by 2x2. We have derived that thing. Okay, this is a maximum torque. Previous classes we have seen. Okay, so this is a torque. Now in this case we can see it. What is happen? So when slip increases, speed decreases. With increase in load, the torque increases and becomes maximum when the T is equal to T max. When SM, that we can say this is equal to S here in this case, S we can say SM, that is equal to R2 by X2. Okay. This torque we can say, this maximum torque we can say the pull out torque, maximum torque. So this is you got it, the your seat in prestigious colleges. You got the state first rank, that is rank. So we can say this is a pull out torque or a maximum torque or a breakdown torque, we can say it. So at that condition we can draw this diagram up to maximum, we can draw the maximum this value. Okay. So this is a maximum torque. Now what will happen? You got the state first rank. Now case 3 or case 4. What is the case 4? When slip is further increases, what will happen? The behind the S is equal to SM. So whatever you are required, the time to spend for the improve your studies is increased more than that. So automatically your health will spoil. That is called, in this case, S is greater than the SM. Then what will happen? The term R2 whole square, here formula what will happen? So here R2 whole square plus j of, that is the Sx2 whole square. In this case, what will happen? This term, your mother and your both will, so dominating the your father. Now in this case, your total product is a very high as compared to your father. You are neglected now in this case your father. Okay, then what will happen? The torque equation directly proportional. What is the torque equation? That is equal to K into S into E2 whole square by, so we are going to get it, so Sx2 whole square. Okay, whole square. Now here what will S will get cancelled, then we are going to K into E2 whole square. Okay, what is the one? Now you can write K into E2 whole square divided by S into X2 whole square. This is the, what is the value? This is a T, torque. Now the torque is, so now we are, torque is equal to, then the torque is directly proportional to 1 by S in this condition. Okay, so what is happen? Your further increases, when the slip is further increased behind the S is equal to Sm, then the term R2 whole square is very small as compared to the Sx2 whole square, and maybe then this value may be neglected. R2 value is neglected. Then we are going to get the torque is directly proportional to K into E2 square by Sx2 whole square. Then T is indirectly proportional to 1 by S. Okay, T is indirectly, this is the value. Then what will happen? So if further slip increases in this case, that means S increase from this value to this increases, then it's go on decreasing. Okay, so go on decreasing. And if the another case, if further, hence the higher value of the slip, the torque slip curve is a rectangular hyperbola. Okay, so rectangular hyperbola. If further increases, then it becomes to this value. Okay, so these are the torque slip characteristics. Okay, so what we have seen? So we have seen that when the first case, when slip range 0 to 1, when S is equal 0, at there is no load on motor, the rotor is running along with synchronous speed, then both speeds are equal, then S becomes to 0. At that condition, in the torque equation, then torque developed equal to 0. In second case, when S is very small, some torque is, S is the slip is some load added on the rotor, due to it retorts, there is a relative speed between the synchronous speed and our rotor conductors, but it is a slip is very slow value, then neglecting the component of with R square. So what will happen here? Sx2 is neglecting, R is dominated, then so we are going to get is torque is equal S into E2 square by R2, then so we are going to torque directly proportional to S by R2. That means the torque and slip is proportional, then the slip increases, torque also increased linearly only. Okay, and that is the second case. And third case, when the slip increases further, that means the load added on the rotor increased, rotor will retorts, then the speed decreases with increase in load, the torque is increases and becomes maximum when, so rotor resistance equal to S times of rotor reactance value. At that condition, it produces a maximum torque. We can say this can be pull out torque or breakdown torque. Okay, now, and that is the torque of this one. So this is the maximum torque. Now, when the torque further increases behind the S is equal to Sn, then the term R2 whole square is very small as compared to the Sx2 whole square and may be neglected this value. So at that condition, we are going to get it. So torque is equal K into E2 square by Sx2 whole square, that is equal T is indirectly proportional to 1 by S. Hence, the higher value of slip, the torque slip curve is a rectangular hyperbola. Okay. So, this is the relations between our torque and slip. Okay. Dear students, it is very easy to understand this relation between this one. Okay. Now, you can see this one. Then we conclude that as this already we have seen. Okay. Now we can see this one. What is happened? So same thing we have seen this one. Okay. Here what is happened? S is equal to 0. This is the second stage when you are ready to study. At your studies is neglected, your studies improved here. When your studies are concentrated 100% here. Okay, what does it happen? 100%, then so it becomes the maximum torque. You are going to get the maximum torque. Then further increases your slip. That means if you added the more load on motor, that means up to maximum load it is running and producing the torque. Okay. So whatever the motor, rotor, you added the, for example, 2 kgs. Okay, rotor is running, slowly running. If 5 kgs, motor is running, okay, no problem. If added the 10 kgs, the motor is running maximum, it will producing the torque and is running at the same speed, nearly up to normal speed. Now, instead of 10 kgs, if you added the 20 kgs at a time, then what will happen? So its speed decreases as well as the development of the torque decreases slowly. If increased under 5 kgs, 25 kgs on the motor, then further decreases. The speed is instead of 1440 rpm, so it is running at nearly 600 and 700 rpm. Speed is very low. Okay, so that is the, if increases further load on this one, that speed will decreases and this one the slip will increases. At one stage, if further increases, the rotor will stop. At that condition, slip will becomes the 1. Okay, so this is known as a T starting torque is developed in the motor. It's time of the starting. Okay, so this is the T full load, T starting torque. Okay, this is a T maximum torque. So here this is a stable region, in this case linear, this is a rectangular hyperbola, unstable region. Okay, already you have seen. Now this is the same thing, torque versus speed. So reverse of this one. Here what is happen? S is equal ns. So this is called reverse of operation. Speed is very high. N is equal, in this case n is equal, this is equal 0. This is a n is equal super speed. Here s is equal 1, s is equal 0. Just reverse whatever we have seen, this one the curve generally. So torque 1, torque would develop, the slopes changes. Okay, so this is the loss breakdown torque when load added more and more. Now effect of rotor resistance on torque slip curve. This is I want to note. what is this one? Okay, we will see that thing. Okay, so let us go to our this one. Now, effect of rotor resistance on torque slip curve. So what we have seen here, we take the same thing. Okay, now here is equal to, you can take the S is equal to, okay, S is equal to 0 and S is equal to, that is equal to, you can take the maximum torque at this condition. Then you can draw this one, this one. So this is equal to maximum torque. Okay, when you have the, this is equal to rotor. Rotor has the R2 plus G of Sx2. Okay, now rotor is running this speed. At S is equal to 0 here, what is happened? The torque is developed, torque directly proportional to the S into E2 whole square R2 by R2 whole square plus Sx2 whole square. Okay, this is the relation. Now, as we know that when slip go on increasing, it torque also increases. Okay, torque also increases. When this resistance equal to this value, it becomes the maximum torque. And beyond that, so it is decreasing rectangle. This is the starting torque. Okay, the starting torque in this case S is equal to 1. That is equal at rotor speed is 0, and when torque is increases, slowly this rotor speed increases maximum. Here N is equal, what is the N is equal? Ns. N is equal 0. Okay, so slowly increasing this one. Okay, slowly increasing and maximum torque is developed here. At that condition, here is the slip, maximum slip is developed. Okay, now in this case, when this rotor value is equal to R2 value is equal, for example, you can take it the rotor resistance, some you can take the, for example, rotor resistance values. For example, you take the 10 ohms. Okay, this value is there. Now, in slip ring induction motor, there is a possible to add the resistance in the rotor circuit. I added some rotor resistance for phase from 10 to, I added some more 5 ohms added. Then R2 second, R2 dash. In this case, I added that 15 ohms, 5 ohms I added, for example. At that condition, what will happen? So here this value increases. Okay, then value increases. The starting torque, so S is equal here 1. The starting torque S is equal, T is directly opposed to the R2. The resistance value increased. The torque value increases in this case. Then here instead of here, I am going to get here starting torque. Okay, I can take another color. Now instead of here starting torque, so go on increasing and you are going to get the maximum torque here, and it's going to this one. That means here initially the slip developed here is only here, but in this case I am going to get it slip at which occurred the SM in this case. That means here what will happen? S is equal to 0. If load is increased on, initially increased on our rotor, so first case, then at some load added, some amount of the load added, it is going to produce only maximum torque at that instant. After that I am going to add it, so what will happen? The maximum torque decreases. But whereas in the second case, if I added the load itself on this one, it will try to take the more load up to develop the maximum torque. That means it can take the more time to take the load. That's I can add, instead of 5 kgs I can add the up to 7-8 kgs. After that it is going to get the maximum torque. After that it is going to decrease. That means at the starting torque also increased. Okay. Now another case, I am going to add the, instead of add the some more resistance on this one. Then what is happen? So I am going to then R3, then R2, we are going to take it R2 double dash. So I am going to the 20 ohms now. Okay, some resistance added, some more resistance. Then I am going to, this torque, starting torque increases. Then I am going to get it. So we are going to get this one. This is the torque I am going to get it. That means here what will happen? The maximum torque developed here further increase. So S is equal to 0. That is at synchronous speed. This is the rotor speed maximum. For example, first case it is going to get the maximum torque is nearly S is equal here. What is the value? For example, this is the 1400 rpm only. It is the red is, it is going to get it. Here what will happen? It will take the 1300 rpm. So it will take the time. Here we are going to the 1200 rpm. That means, so what will happen? The slip S is equal 1, standstill position. So here the slip at which it occurred is changes. The slip for maximum torque increase with increase in the R2. Okay, the T maximum is same, but so here you can the maximum torque in this case, the maximum torque, magnitude of the maximum torque is the same. The maximum torque is same, the independent of R2, but the slip for maximum torque increases with increase in the R2. So R2 increases. So here is, this is a this one stage, this is another stage, this is another stage. Okay, so the slip for T max increases with increase in R2. The starting torque increases. You can see this is the starting torque for the first case, this is the starting torque in the second case, this is starting for a third case. If further increases R2 dash dash dash, then for example 25 ohms, then we are going to get it directly. This is the maximum torque. This is maximum torque equal to the starting torque also. It is possible when R2 is equal. What is the condition? So when R2 resistance is equal to X2 value, then so motor will develop a maximum torque. Okay, so that is the value, that is at the instant of this value. Okay, so this is a effect of rotor resistance on rotor slip curve. Okay, so what we have seen, so once again I am going to try to explain it. So T max, what is the formula? So T max is equal to, we know that formula already. T max is equal, maximum torque is equal to, so some proportional constant into E2 whole square by 2x2. Okay, this is the maximum torque, magnitude of this torque. This magnitude of the torque is the same for all cases. Whether you are going to add the more resistance, the what is the magnitude value is the same, but at which it occurred is the changes based on the, that means the speed and the slip changes. You can see it. When no external resistance added, then Sm is equal to, what will happen? So R2 by X2. If rotor resistance is increased from R2 to R2 dash, so in this case T max is unchanged. Okay, but slip for maximum torque is Sm dash is equal R2 dash by X2. So every time you are going to the, what is the formula? Sm is equal to R2 by X2. Okay, now second case Sm dash, second case R2 dash by X2. Okay, so here the changing these values. So first case, second case, third case and fourth case. So for example, this is, take the maximum 1000 rpm. Okay, now it is go on increasing at 0 speed. So what will happen here? This is a max. After that, so it will stall. So finally we are going to conclude that the maximum torque is same independent of rotor resistance, and slip for maximum torque increases with increase in rotor resistance. The starting torque increases with increase in R2. Here the starting torque increases with increase in rotor resistance, but maximum torque is the same. That's why. So what is the starting torque? That is a pickup. That is a pickup. So dear students, please remember this one. For example, some vehicle, two-wheelers. What will happen? Some two-wheelers initially when it's a kicked, that one, if raised, so it will automatically, some vehicle will take the time to pick up for example 50 meters or 25 meters, will try to take the pick up the speed. And nowadays we can take that some KTM two-wheelers or some high horsepower vehicles, Pulse or something 250. That's it. So what will happen? Those are the very quick torque develops. Pickup is more and more. But some vehicles will take the time to pick up to some distance. And brake power as well as the pickup time is a very high some vehicles. Similarly in this case also, that means here what is the pickup? It is just like it's a normal vehicle, Splendor. It will take the time to pick up. For example, you take it, this is the Pulsar, it will take the easy time, and it will take the KTM vehicles. So there is a pickup is a very high. Instantly we can raise the speed. So that can be possible by adding some resistance into the rotor circuit with help of a rotor rheostat. Okay, so this is how we are going to, just like this is a slip ring induction motor, just like in case of the DC series motor. What is the DC series motor? The high starting torque DC series motor, whereas a shunt motor is a normal starting torque. Here suppose I want to require the three-phase induction motor, so I can prefer for the starting torque where we require the more torque is required, I can prefer for the slip ring induction motor comparing with the squirrel cage induction motor. That's why it can be used in the lifts, where lifts it will pick up the initial load. Hoists, different applications we have this one. Okay, so these are the relations between the rotor resistance on rotor torque slip curve. Okay, so this is a one thing you remember that. Okay, now let's go that one. You can see this one. So what has happened here? So in first case, this one, this is a starting torque when resistance is called R21. Okay, once resistance added, then what will happen? It is going this direction initially. So this is the same, but what will happen? So instead of here we are going to get in this case, that is the slip changes. Here slip changes, and if resistance increases further, so we are going to this one, further we are going to increase. So these are the different starting torques for the different. So this is the one starting torque, starting torque, starting torque, starting torque increases, and slip at which it occurred maximum torque also changes based on the resistance values. Okay, so this is one thing observe from this torque slip characteristics. Now effect of supply voltage on torque and speed. So as we know that, so once rotor pickups, it will take the current from the supply. So what is the current? What is the voltage in effect on stator winding? Okay, so here you can observe it. So this is the full voltage torque, and this is the current torque. Slowly voltage so go on increasing, this is just like is a torque, and this is a correspondingly current. What is the relation? So relation is nothing but here you can see here. So we know that the torque is equal to, what is the formula? Torque is equal to proportional to K E2 whole square S into R2 by R2 whole square plus Sx2 whole square. Okay. Now, what is the torque? Torque directly proportional to S into E2 whole square. So, what is the E2? That is equal torque is directly S into V square. That means here the torque directly proportional to the V square. What is the V? Supply voltage. That is why it is the drooping characteristics. Correspondingly, once voltage increases, then increase the current will also, initial current is this one is go on decreasing current up to this stage. Okay. Now, you can see the rotor speed. So, rotor initially standstill condition, the current will take the current, starting current. We know that what is the starting current? Starting current is equal 5 to 7 times of I full load current to develop that starting torque. So, that pickup will rotates the rotor. At that condition, the voltage this much. Once the torque is developed, the voltage also increasing and torque also increases up to maximum, the current will decreases based on this equation. Okay. So, these are the relation between the torque versus supply voltage. So, we have already seen that three-phase machine can be run as a motor when it takes the electric power and supplies mechanical power. So, here is one doubt. I have the one doubt. What is that one means? Here you can see it. Dear students, for example, this is the, please carefully listen it. This is the stator. I have some doubt. I have given the three-phase supply. Okay, 50 H supply. I connected to some supply, grid supply. Okay, so I connected to the PSSC poles nearby my house. I connected. Supply is connected. Okay, now then in this case, the rotor is running and it is mechanically coupled to our load. Okay, it is running. It is running. This is enough. Now it becomes, what will happen? Here the current which is taking from the supply okay, the current which is taken from the supply and it developed its RMF, rotating magnetic field. It produces the torque and rotates the speed, some RPM, N R it's the rotating. Then it acts as a induction motor, because whatever the power developed from the stator to rotor flows through the induction principle in the form of magnetic field. Okay. Now, there is a one doubt. Suppose what will happen if supply is given to this one, it rotating the mechanical output, okay, mechanical output. Now, second case, if I rotated this one by external means, then it will generate any electrical energy that is I required. If electrical energy is given, the mechanical energy given in the form of rotor. If I given the mechanical input to this one rotor, it is generated electrical energy. Why not? It will generate the electrical energy. Then it becomes the synchronous generators, induction generator. Instead of induction motor, then it will become as a induction generator. How it is possible, sir? Yes, it is possible. If the speed of the rotor, so because what will happen, the rotor speed always less than the synchronous speed, in this case synchronous induction motor. If rotor speed is greater than the synchronous speed, then it becomes to the induction generator. So not only synchronous motor, it will act as a generator and motor, or induction motor also act as induction generators. Sir, there is any applications about this one? Yes, we have the applications. So what we have seen in outside, there is a windmills. Okay, windmills, there is a connected windmills to generation purpose windmills. So here they provide the induction generators only. Induction generators, where it will rotate the rotor speed more than the synchronous speed of rotor. Then it acts as induction generators. Okay, that is the one case. At the same time, suppose it is running, we can apply the braking. Yes, if the load is added, it acts as a braking. So that means here the induction motor works as an induction motor mode, second mode induction generator mode, and third one is the braking mode. Braking mode. 3 modes it will performs. Okay, induction. So where is the induction motor? It takes the electrical energy, it will give the mechanical energy. Now it is the take the mechanical energy, it will give the electrical energy. Braking mode, it is the stops the rotor. So 3 operations can be performed in induction machine. Okay, let us see that one. So when we have already seen that 3-phase machine can be run as a motor when it takes electric power and supplies the mechanical power. The direction of the torque and the rotor rotation are in the same direction. That means here the torque, so whatever the torque is developed in the rotor torque developed in this direction, and rotor speed, that's a rotation also, both, that's a n, both are same directions. Then it has a induction motor. Okay, now the same machine can be used as an induction generator when driven at a speed greater than the synchronous speed. Here what is happened? The NR is greater than NS. How it is possible? So by external means. External means, so we can run the rotor speed is more than the synchronous speed. Then it acts as a induction generator. In this case, it receives the mechanical energy in the rotor and supplies the electrical energy from the stator. Okay, it supplies the electrical energy from the stator. The torque speed are opposite direction. In this case, for example, torque is this direction, then speed is the another direction. Okay, previous case same direction, here in this case the another direction. We will see the one graph also. The same machine can also be used as a braking mode here. So brake mode. The plugging period. What is the plugging? So we will see the plugging. Okay, the 3 modes of operation depicted in the torque speed curve as shown in the figure. You can see here clearly. So here, so this is our normal position. Now we have seen what is that one? The here n is equal to 0, and the torque, initial torque, starting torque, the torque is slowly increasing to the maximum torque. After that, okay, so this is the torque is slowly increasing up to maximum. So after that, so go on decreasing. This is the motor torque speed characteristics. Okay, so here what is happen? Here what is the input? The P1 is electrical energy, P1 is given, and there is a stator copper losses, stator iron losses we deducted. Then we are going to the P2 stator output, that is the rotor input. From that one, so we have taken out the rotor copper losses and friction and windage losses in the rotor. So we are going to get the net mechanical power developed in the shaft we are going to get. So this is already we have seen in motor conditions. Okay, now so you can see here what is the torque and speed are both directions in this motor. Synchronous speed is this direction and the rotor speed also this direction. The torque developed also this direction. All are same directions. Then it has a induction motor. Now what will happen? So I have, in this case you can see, in this case you can see it. What is happen? In this case the synchronous speed the clockwise direction and rotor speed also clockwise direction, but the torque developed is the opposite direction, anti-clockwise direction. In this case what is happened? Here the mechanical power is given to the rotor. Same friction and windage losses and rotor copper losses, that is here the rotor P2 is the rotor output, that is the stator input. From that one some iron losses and copper losses. Then we are going to get the P1 as a electrical energy. So that means it will give the electrical energy. Then we can say is a generator condition. Okay. So what is happening here? Here the torque is rotating in anti-clockwise direction and our rotor speed is the in clockwise direction. Okay, so then we can say the synchronous, that is the induction generators. This can be used in windmills to generate the EMF. Okay, so this is the motor principle, this is the generator principle. Now you can, another mode is a braking mode. So you can see this curve also. Here you can see the what is the happened curve of the this one generator, reverse of motor, reverse generator, this one. Now if we extended this one, what is that called? Here the n is equal 0, n is equal synchronous speed. Now the speed is reverse, minus ns, you can see the minus ns. What will happen? It is a go on decreasing this one. We are going to, this is the torque. So this area we can use the braking mode to stop the motor. In this case what will happen? The torque is in the same speed of the ns, this direction, and rotor speed is a reverse direction. Rotor speed is a anti-clockwise direction. Okay, then so we are going to get it. So what will happen? It will take the power from the electrical energy and it will take the mechanical energy from outside. So in this case what will happen? So the motor, so only one direction, electrical energy it takes, it will give the mechanical energy. Whereas the generator, it will take the mechanical energy and it will give the electrical energy. Both are same direction. But in this case what will happen? Electrical energy it is taking and mechanical energy is taking. So that is the friction will takes place here. So what will happen? The mechanical energy is taking from the shaft, electrical energy taken from the stator, it is developed the same all losses. That this stage is known as the braking mode. Okay, so braking mode, that is known as the plugging. We will see later that one. Okay, so these are the some modes of induction machine. Same thing they are depicted here. How that the torque, maximum torque, starting torque, and everything. So you can see the starting torque and the maximum torque is occurred, and is in case of the motor, in case of the generator, and this is a braking mode region. Okay, so we can see this in details in BTech level. Now synchronous watt. What is the synchronous watt? Already we have explained the synchronous watt. That is the rotor input. We can say synchronous watt. It is clear from the above relation that the torque is proportional to the rotor input. The rotor, that is the P2. By defining the new unit of the torque instead of the force at a radius unit, we can say that rotor torque equals the rotor input. The new unit of synchronous watt is nothing but that. Okay, so already we have seen last class. Synchronous wattage of an induction motor equals the power transferred across the air gap to the rotor. Whatever the rotating magnetic field in the stator is transferred to the rotor input in the form of magnetic field, that is known as the synchronous watt. The torque in synchronous watt is equal to rotor input is equal to rotor copper loss by S, that is S into rotor input is equal to rotor copper losses. Okay, that is called gross output power Pm by 1 minus. We can write the different equations. Obviously, at S is equal to 1, at standstill is equal to 1, torque in synchronous watt equals to the total rotor copper loss, because at that condition there is no mechanical friction and windage losses developed. At that condition, at standstill condition, whatever the input is given, that equal to in the form of rotor copper loss. That is why rotor will heat very high value if the bearings are failed. If the bearing is unable to rotate the rotor, some clogging takes place. Then what will happen? If supply is given, then it will continuously heat will takes place. Dear students, you can observe once sometimes we are going to switch on the supply for the fan, ceiling fan in our home. If condenser is fails, what will happen? If switch on that one, it will give some humming sound, but it will not rotate it. After few seconds or 1 or 2 minutes, then switch off the supply and you observe the heat evaporated in the fan. The heat may be very high. So if continuous for that time, what will happen? The winding will fails, the winding will burn out. How the heat is generated? As per our copper losses. Similarly, here is also that initial S is equal to 1 standstill condition, whatever the rotor input P2 equal to the P copper losses only. Okay, so at standstill, so entire rotor input is the lost as a copper loss in the form of heat energy. Okay, so this is the synchronous watt already we have seen. Okay, so what we have seen in this class, we have seen that relation between the torque versus speed and the torque versus slip, and how the resistance changes the starting torque of a induction motor, and how this induction machine can be operated as an induction motor, induction generator and braking mode. And then the same lastly we have seen, recalled once again, what is the synchronous watt of induction motor. Okay, so dear students, so these are the today topic, simple topic and easy topics. Okay, thank you for listening my class.